if I have 48 divided by something smaller, and this actually is a little more than 48, right? This is actually bigger than 48, and this is actually smaller than 4, I will get more. Because I'm increasing the amount and dividing it by sharing less, right? Sharing with less. Then my amount is bigger. So it's logical too, right? It's logical. Right? It's very logical. That's a great way to check. Because at first I call, is it going to be bigger than 12 or less than 12? Right? And once you do it, right? So you think about it, if I say 48.279, so this is bigger than 48, right? As I say. So bigger than 48. And this is less than 4. Right? So if you have one number that's bigger divided by one number that's smaller, I will actually get more. Now, it was funny because in the beginning, everybody said, oh, it's going to be less than 12 because you saw that this is less than. Right? You saw that this is less than. But when you divide by something, you actually come up with more. Okay, think about sharing. When you divide by something less, you actually come up with more. So many of these problems are like that. So you could, I think this is a section for practice. It's okay to use your calculator, but try to do it logically to do what I just did. Like try some numbers that are clean, and then see what you think your ballpark should be. And see whether you can guess. And the more you do it, the better you are at guessing the numbers. Because you got practice. It's like, yep, I can see it quickly. Yep, it's about 50, this is about 40, or this is about 20. Numbers that are easy to divide. Easy to see what the answer is. Okay. Is this helpful? Okay, yep.
Can we do some area and perimeter
problems
for triangles?
Yep, so these are all measurements. And everybody should have the formula sheet. And again, some of it is, and we'll do some of the area and things. I don't know how much of the one with the sphere, you'll get answers for that. You might only get the linear ones. I don't know. I'm gonna check on that because I remember looking into NES, and I remember it talks about how they will never have problems that are bigger than a certain number. They will not have problems that are equations that are beyond the x1. Okay, you won't have x squared. So I'm trying to figure out for measurement whether they will have problems that has like the V equals to 1/3 LWH. And if they do have it, they may give you the formula and figure out whether you know how to use it. Right? Figure out whether you know how to use it.
It's only the first part, the basic one.
Yep, the area facts, I think so. That's what I'm thinking. Yeah, that's what I'm thinking. So concentrate on those, like the flat ones, right? The area, the triangle, and the circle. Right? That's what I'm thinking too. All right, give me one.
So page 37, basically any of those.
It's so nice to have page numbers. Oh, I see. There's actually a page on there. I did not know that. So yeah, Dr. Hartleb just printed the other one, but it's nice to have it on the outside. All right, page 30. No, what is that? 20. What did you say?
37.
37. Sorry. May I? Yes.
You went right to it, huh, Mariah? This is how you feel?
What do you need?
I see. Sparking my thought process.
Okay, emergency? Okay, did I just?
No, it's not.
Okay. All right. You know, nowadays, oh, this looks like my phone. Do you have a C there? Yeah, that's a C. I have a C. No, did I bring it? No, I don't.
I do. I have a 5S charger. I need that.
Ooh. Yes.
Which
Which one? This one?
Yeah.
Oh, you want to multiply it anyway?
Yeah.
Even though I don't multiply properly. Okay. So in order to do a problem like that, just to make sure, right, everybody knows how to do it, I would make sure that I line up the 3 and the 0. Okay? Because this is like saying that it's multiplied by 3, but I'm going to get the whole answer and multiply by 10.
Wait, what number are you doing? Sorry.
This is just the one, we just want to do one, okay? So I'll put the 0 there, and then 3 times 3 is what? 9. 3 times 27, 3 times 0 is 0, so it's 27. 8 times 6 is 18. And 3 times 1 is 3, so it's 4. Now it's 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Right? Again, if you don't know where to put the dot, think logically.
Yeah.
Right?
Yeah.
If I have about 1.5 times 30, my answer cannot be 482. Alright? And my answer couldn't be 4.8. Right? Again, think logically. Right? 1.6 times 30, that's 30 times. I cannot have my answer before, and I cannot have my answer before 482. That's too big. Right? So that's sometimes how you know where you should put it.
Well, I said I took the 0 out and then I put the bond when I was multiplying. I put the bond.
Put the
She took the 0 out.
put the 0 out.
And I put the bond.
Now, if you did this, this will be here, right?
No, the bond is going to be after 6 when it multiplies. In the middle.
Oh, she said you put the 3.
Oh, right here.
Underneath the 0. She put the 3 underneath the 0.
Like that?
No. Okay, take out the 0. You're not done?
Right here?
Yeah.
Oh, you like that?
No, At least did you take the reading and writing? Did you take the reading and writing? Just take that one. If you have no class, do like one of the practice.
Did you get the same answer?
Take it.
Did you get the same answer?
It's like regular, you need to pass.
Yeah, you can do that. Absolutely. You can do that. Yeah. You make sure you multiply by 10 first before you multiply by 20, right? Absolutely. When you multiply by something, you can multiply any order. You can multiply 3 first, or 10 first, or multiply by 10 first, and then 3 later. Up to you. So you just did it the other way, which is amazing. That's great. I have not done it that way for a long time. That's a really good thing. Did everybody know what she just did? That's actually a very good thing. So 1.6, I'm just going to say 6093, right?
Yeah.
Times 30. I'm going to write this and see what do you agree. It could be 1.6093 times 10 times 3. Or it could be 1.6093 times 3 times 10. Does everybody understand the difference? They should be the same. There is no difference. But what she did was that she actually did this problem first. And then when you did this problem, it becomes 16.093 times 3. Isn't that, I mean, it's great. Because in multiplication, you can do it however you want. The way I did it, I basically put the 0 at the end by multiplying 10 at the end. It doesn't matter, you get the same answer, right? So when I did it this way, right, then I multiply by 10, I put the 0 at the end. Yeah, I put the 0 at the end. So it really doesn't matter. Multiplication is really nice that way. Make it whatever easy for you. So for her, multiplying first was easy. That's fine. That's interesting. Okay, let's do triangles. So what's the connection between triangles and rectangles? What is the connection?
Triangle is half of the rectangle.
Does everybody hear that? Say that again.
Triangle is the half of the rectangle. Triangle is the half of the rectangle. If you visualize.
Oh.
Think about that. Yeah. If you think of it this way, actually in elementary school, many of the curriculum will actually have an activity when kids literally take a piece of paper and make triangles out of it. And then they rearrange it into a rectangle. And you realize that every time you do it, it's half of the rectangle. No matter what shape of the triangle is. Right? So that's the relationship. Right? So think about it conceptually. If this is L times maybe height, I don't care what you call it. Then the area is what? L times H, right? If I have, this is H and this is L and it's a triangle, it actually doesn't matter whether it's a right angle or not, it really doesn't matter. Then what is the area here? Yeah. Right. So knowing that relationship makes a lot of the problem very easy. Whenever you have a triangle, make sure you know what is the base, how long it is, and what is the height. It doesn't matter whether the height is this way, right? The height could be this way and the length could be this way. It doesn't matter when you have one that looks like this. Okay? This is still the length, right? Is the height here? No. It has to be, yeah. Okay? So that's the height.
Is that an isosceles triangle?
I don't know because I didn't draw it very well, so it might not be anything. So, because isosceles asks that you have two sides that are the same. Okay, those
Oh,
are the
that
same.
is, oh, I thought it was unequal.
No. Okay. So if you understand the original idea of area of rectangle and triangle, every problem you do in triangle is to understand what is the length and what is the height. Right? Recognizing that height, then you can find the problem. Okay. Yes.
Sometimes I put two triangles side by side and then with various heights and various lines.
So you need to figure out, right? Like it will tell you like this is 3, this is 4, right? Then you have to go, wait, what's the whole thing? How long is that? It will trick you that way, right? Because they are putting two triangles together. Now you could do separate triangles too and add them up. You will the same answer. Right? Like this one here, I could go this, 3H, and then I should go the other direction, 4H. I can just add it up, it will be the same in terms of the area. Okay? So whether you do it separately or you do it as one triangle, you should get the same answer. You should get the same answer. Because area is about pieces adding together, right? Area is like the surface. So you're adding pieces together. So sometimes you might have a problem where they are different shapes, and you have to be able to see this shape is a triangle with this height and length. And then this shape is a triangle with this height and length. This is a rectangle. And I'm going to add all those areas together. And there are problems like that.
So area is length times width times height, and perimeter is divide the area by 2, right?
For what? No?
Length times height.
Oh wait, sorry.
Yeah. So for parameter of a rectangle, think about parameter is going around, right? Going around. So it's L plus H plus L plus H. Okay, so this is area.
Okay.
We're geometry now, so let's
Oh, I see. You're looking at right at the, yeah, okay.
Okay.
She's looking at page 37.
Ah,
And it
okay.
has the perimeter on it.
Yes. Oh, good. Let's. Okay. All right. Let's
I had to
focus.
look at that too.
Yes. Yeah. Yes. 37. Everybody look at 37. Page 37. And they want you to look at area and
Oh, and
parameter.
even at what you were talking about just a second ago, the isosceles and all that. Yeah, and I was asking the type also with it.
Yeah, the type. Okay. Page 37. No, in that one. Yeah, in the geometry. So area means the inside. Area is the inside. That's one way to think about it. And parameter is the outside. Okay. And the way I think about parameter, kind of like in real life, the word parameter is like a boundary, right? If you look up the word, parameter means like a boundary, right? The parameter of something that means there's a border, there's a way that is, kind of like surrounding something. So remember the parameter is the outside and the area is the inside. Okay? So for rectangle, it's actually pretty easy because you multiply. Think about it this way. The reason you multiply is because you're counting all the squares inside. Think of it. Remember I talked about the area and multiplication? When you talk about area, you're really counting all the squares inside. That's why you multiply. You can just like one at a time do it. Like if this was 3 and 4, you could just count them, or you could multiply. So the multiplication is not magic. It's because area has to do with counting all the area inside and all the way that it's taking up space. Okay? Parameter is as if you're walking around. Okay? You're walking like somebody who's surveying, you're walking all the way around. Okay? That's perimeter. So imagine walking around. So then if you walk around, there's an L, there's an H, there's an L, and an H. Right? So you could think of it as 2L plus 2H. Or you could also think of it as 2 times L plus H. Either way, doesn't matter. Right? However you think about it, doesn't matter. For rectangle, it's easy because it's always repeated, right? Rectangle means the two sides are the same, the length are the same, and so you can add them up. So think about walking around, okay? And then you count out all the squares, right? Count out all the squares. Now the area is a little bit different because one of the lines are slanted, and I don't know whether they'll ask you this question, but you really should know this because by 5th or 6th grade they might actually do this problem in elementary. So for area is half of LH, right? Because we say that you could almost imagine a rectangle, right? Same thing here, you could actually imagine a rectangle. On all these problems, you could actually imagine a rectangle. Okay? That's the reason it works every time, which is kind of amazing. It works every time, okay? No matter what the shape is. But then for parameter, if you're going to walk around, what is going to happen? You're going to have the L, right? And then plus H, and then plus the side. So how do you find out the side? Anybody? Remember how you find a side that is slanted? Huh? There's a formula. It has to do with you can only happen with this right angle, right? Not always. It doesn't always happen. Does anybody remember Pythagoras theorem? I wish we have time because when I taught this problem, we don't talk about Pythagoras for the longest time. We talk about what?
That's in here.
Is it there?
Yeah.
A squared plus B squared equals C squared.
Yep.
I knew that.
Yeah, A squared plus B squared equals C squared. Again, if there was time, there is an activity I do with young kids where they actually can see that like, wow, the A squared plus B squared equals C squared there's a way that you can put shapes together. It's very interesting.
Fifth grade.
Yeah. Yeah.
It was like fifth through like middle school.
Yeah, middle school. Yeah. Yeah. They may not understand. Yeah, they actually can do it because visually they can see it. Yeah. They may not do some of the major problems about it, but they understand the concept. Yeah. It's actually very interesting. Because I learned it very late when I learned it. But nowadays kids it's visually they can see it. We didn't do it that way, right? So that's what we remember the formula. So the side. But this is only true for right angle, okay? If it is not a right angle, you can't do it. Right? It's only true for a right angle. The Pythagoras theorem only works if it is
90 degrees.
right.
Which would be like number 6, 2, 6, and 8, right?
But they actually give you, don't they? They give you a set. See, they actually give you the side. So I'm not asking you to do Pythagoras. They actually give you the side and ask you to add them all up. So in this case, this problem doesn't require Pythagoras theorem. But there might be other steps.
Why do they have the little square in the corner?
Square means right angle. Right angle. Yep. Little square means right angle. Yep.
Page 40.
40?
Actual, yeah, 3.
But they-
Oh my God. Okay.
Theorem problem.
Okay.
What page is that?
40. So let's just pick something.
That was just the next.
Is there someone who has taken the test that like knows?
Oh, here we go.
I'm like, I don't know any of this.
Are there any?
Yeah, there were a lot of people that had failed it.
Yeah, I don't know if you have to do this, but it's not a, once you know the formula, it's not bad. So which one do you want me to do? Just do one. Just do one.
Yeah, we can do the first one.
The first one?
Yeah.
So could somebody read that problem?
Carl walked 4 meters west and 5 meters south. Calculate how far he is from his starting point.
Okay. So you know what, this is again not about knowing the formula, but knowing what the problem is asking, right?
So
That's
right
different.
away, couldn't you do, oh no.
Okay, let's think, let's just
You were
follow
taking 4
along,
times 5?
right?
And then
4, west, which direction? Let's think how is here. Okay guys, to the left or right if I go west?
always W-E.
The left.
To right.
Left.
My teacher.
I had to
The
think
way I
about it.
remember is that Minnetonka is on the west side, so. So I'm gonna say Bulge on the east side, so. So I go 4 meter west, yes?
Yep,
Oh, when I think of West Coast is LA, San
That's how-
Francisco,
that's
that's
how
how
I
I
think
think
about
about
it.
it, right? The East Coast is New York, that's how I think about it, and we are right in the middle. So that's how I think about east versus west, yeah. North and south is a little easier, so, 4 meter west, and then what else?
5 down.
South, so down,
Yep, 5.
okay. All right, and what is the question? Calculate how far he is from his starting point. Where is his starting point? Right here, right? This is start, and where is his ending point?
Down at the bottom of your
Right
arrow.
there, right? End. So what is the question asking?
How far is he from the starting point?
So I need to draw this imaginary line here and say how far. Ah.
Because they want you to use the Pythagorean theorem, so we don't have to even think about it, we just plug it in.
Well, but you need to first draw it, right?
Yeah.
Because you don't draw it properly, your A and B and C will be wrong.
Okay.
So just because you know the formula, you got
Oh,
to
this
plug
is
it into
big.
the right place, okay? If you got this wrong and you put 5 here or something, then you will never get the answer. So understanding the problem is important. Draw it out, okay? 4 across, 5 down, and how far, I mean, in real life, you think about how far, it is that line. You're not just doing it because it's a Pythagorean theorem, it is that line. If somebody asks how far is he from the starting point, you will look at this point, okay? So, and so how do I know that this is a right angle? What tells me? How do I know that this is a right angle? Well, because you go west and then you go south. It didn't say southwest, it didn't say 30 degrees somewhere, no, it says straight south. So that's how you know that it's right angle, okay? So then, if this is the distance d, then what is the equation that I can say? D squared equals to 4 squared plus 5 squared. Everybody got that?
So it actually is that, so it's,
16 plus 25,
yeah,
which is
41.
41. So D is square root of 41. Now, this is again, they may not give you square root of 41, depending on what the answers are. Now, if you don't have a calculator, what do you think is the approximate answer?
You try to go 6, because 6 times 6 is 36, so you
Right.
take 41, and that's the closest, and then you're gonna start with a 6.
Yep, so you could again use estimation, right?
Hold on, we're-
Hang on, let's just she did this in her head, right? Yeah. So D equals to square root of 41.
The same thing times the same thing.
Yeah.
Right,
So, 25,
okay.
6 is 36.
Okay,
Now I get it. Now I
so,
get it.
so square root just means that there is a number such that something to sometimes something give you 41,
Yeah.
right? What are the roots? What are the square numbers?
6
Let's
times,
start from the beginning. What are the square numbers?
Okay.
What are called square numbers?
they're times
So
one,
one,
1,
1,
2,
4,
2, there's 2, there's 2, it's not very pretty.
4, 4,
4,
3,
4.
What times
Two
will
is
give you
4.
3? So I'm talking about square numbers, not the root.
Oh,
Okay?
So
So
4,
if this is the root,
so 4.
okay? 1, 2, 3, 4, 5. Then the square number,
1, 4, 9,
yep.
16,
1, 4, 9, 16, 25.
And
6
36.
is 36.
Yeah,
7 is
49.
49.
64.
So you know that your answer is between
36,
6 and 7.
Yeah.
Can
Okay.
you leave it alone at that though? Can you leave it at
No,
square
but
root
you
of
can
41?
guess at that
You can
point.
guess.
You can,
Yeah.
Okay.
use the
Yeah,
elimination.
it depends.
You got, yeah.
Sometimes it will say your
Should be
answer is
multiple
square root
choice.
41, square root 36, or square root something, and you know that the answer is square root 41.
Okay.
Sometimes it will actually convert and make you think about which one is the closest. I know. So in that case, then knowing what it means to be a square root is important. Now, these are called square number, partly because, guess what? These are all squares, right? These are all squares.
They're all
3 and 2
proportional
have 2,
values.
right? These are all squares.
What's a root?
A root means what multiplied by what give you that square. That's what square root is. Root means that it's a square root, means it's the number that when you multiply by itself, it will give you the square number.
So in the case for the answer instead of 6?
No, it will be, we want something that multiply by itself gives you 41. So it will be
6, 40,
between
so then you
something,
have to do
right?
6 into 40, which would be 6 again, so 6.6.
Then that's the answer. Right, but if it is not, right, then you know that your answer better be closer to 6 point something, right? Because 36 and 41 is a lot closer than 49.
If they don't give us the square root.
Exactly, right. So that the estimation will be what you can think about. Okay, how do I know? Because then it's testing you whether you understand what square root means, right? Right? Because in a lot of times the estimate is good enough that I know it's not a 2, I know it's not a 4, I know it's not a 7, it's not a 6, it's somewhere in between. Right? So the answers might be somewhere in between. Okay? So square root is a very interesting kind of, again, a term in language, right? Square numbers are fun because they are so nice. Right? They multiply by each other, or then they multiply together. Right? 5 times 5, 6 times 6, 9 times 9. Right? Kids love square numbers. And now we talk about square numbers in terms of area. That makes it also easy to draw, right? Square numbers are like basically a square with the same sides on both sides. Okay? Another one? Any other so let's do, how about circle? Oh, let's talk circles for a minute. I'm going to give you another way of looking at circles, okay? Yep. What does the word pi mean?
3.14.
3.1.
3.14 and blah, 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 just like forever number. It never ends. Okay? I actually did this. This is a real story. When I was teaching middle school math, we have pi days. What are pi days? Not the pie as in the eating pie, but
March 14.
So when do you think Pi Day is?
March 14.
March 14th. Yeah, 3.14. Okay. So what we did was my whole class we had construction paper with color in the strips of different color. Each digit is a different number. We even have a legend. 0 is pink, 1 is blue. I don't So all the numbers, and then they actually have to do a pi number that is maybe like very long. So they did one that was like 20 digits or 40 digits. And they started like doing those, what do you call those things? Those little chain, there you go. So we actually did it where we started with the number 3, dot, and then we have a chain that went all the way around the hallway. And we tell people that's pi. Because you can't even see a pattern. That's the amazing thing. That when you look at it, every number next to it, it's not like you could say, every 5 is a blue. No. The numbers are so amazing that you keep going, and you keep going, and you keep going. Okay? So kids were like, oh, my turn is it's a 1. They put the little loop, and then, it's blue. Now they put the little loop. So it became actually an art activity. And then they have to explain to people, what is this? What is this thing, around the hallway? That's pi. 3 point, and then they go 1, 4, and then whatever the number is, and you can keep going. Yeah, it was an art problem. Yeah, they had fun with it, right? So when you think about circle, so this is what I wanted to maybe end with, because you'll be doing circle problems a lot. So what is this called?
Radius.
Radius, right? Radius.
I actually do remember this one.
Very good. What about diameter? What is the diameter?
The
whole
whole.
So what is amazing about circle is that the radius is the same if you start from the center, right? And same thing with the diameter. So I can just say that's the diameter. However you want to cut it, but it has to be from the center, right? If it's not from the center, it doesn't work, right? So what is the area again? What is the formula?
Pi squared.
Pi r squared. Okay. So how do you remember this versus what is the parameter? Yeah, what is the parameter?
Around the
Two.
outside.
Around the outside,
Yes.
2 pi r. Or
Oh,
you could
so
also
the
say pi d.
circumference?
Oh yeah, they don't call it parameter, I'm sorry.
Yeah, that's what I thought.
Right, they call it, it's a special name. It's a circumference. I can't spell it. Did I? Yeah.
It looks close enough to us.
Circumference, is that all right?
It's fine, like.
Close enough, yeah. So it's just a special name for a circle, okay? It's really parameter, right? You're going around on the outside. So I want to help you think about this so that you can remember it. What does it actually say here? If pi is about 3.14 something, right? What are you saying here?
You're multiplying the radius.
So the radius is
Radius
here.
squared.
Radius is here.
So the
Yeah.
radius is
So
already
radius
squared.
square is a square, right?
Yeah.
So it's r.
Yep.
What I'm saying is that I could actually fit a little bit more than 3 times the radius square. And kids actually do this. That I could actually go and put like a radius here. That I could actually do this. And I'm not doing it correctly. Okay? Then you could actually fit 3 circles, and then whatever is left over, you put it over there, and you realize that it's a little bit over 3 times. Oh, so it's not just a formula. It has meaning, right? Try it. Go home and try it, because my circle is not very good. My circle is not good. But if you actually did it, draw a nice circle,
Yeah.
and then cut out the squares that are the size of the radius.
Radius squared.
Radius square.
Okay.
Right?
Oh.
And then you take the 3 of them and fit it inside, and then cut all the edges and put it all like, oh, it's a little bit over 3 times.
Where were you when I was in high school? Oh my God.
Where did it come from? Yes, yes. It's not magic, because you know what? That means somebody realized that every time you do it, it's about the same. That a circle can fit a little bit over 3 times that radius square. But once you know it, it's kind of go, oh, that makes sense, right?
Everybody here is like, the teacher, whoever you learned it from, should be fired.
Yeah, my high school teachers need to be fine.
Well, I would say that math, traditionally, like when I learned it, was very much about do 50 problems, find the formula, and plug it in.
Yeah.
How do you
No
do that?
explanation.
Right? No explanation, no